charges.
Unlike charges acquired by the objects, neutralize or nullify each other's effect. Therefore, the charges were named as positive and negative by the American scientist Benjamin Franklin. By convention, the charge on a glass rod is called positive and that on silk is termed negative. It is verified that the force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to the other charges, taken one at a time. The individual forces are unaffected due to the presence of other charges. This is termed as the principle of superposition. Thus, the total force F1 vector is equal to F12 vector plus F13 vector. F12 vector is equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by R12 squared into R12 cap. F13 vector is equal to 1 by 4 pi epsilon naught into Q1 into Q3 divided by R13 squared into R13 cap. Thus, F1 vector is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 squared into R12 cap plus 1 by 4 pi epsilon naught Q1 into Q3 divided by R13 squared into R13 cap. By the superposition principle, F1 vector is equal to F12 vector plus F13 vector and so on till F1n vector. This is equal to 1 by 4 pi epsilon naught taken common, and within brackets we have Q1 Q2 divided by R12 squared into R12 cap plus Q1 Q3 divided by R13 squared into R13 cap and so on till Q1 Qn divided by R1n squared into R1n cap. So, by the superposition principle we get F1 vector is equal to Q1 divided by 4 pi epsilon naught into the summation of I from 2 to n Qi divided by R1i squared into R1i cap.
In the previous section, we found out the total force F1 on a charge Q1 due to two other charges Q1 and Q2. Vector F1 equals vector F12 plus vector F13, which equals 1 by 4 pi epsilon naught into Q1 Q2 by R12 square into vector R12 plus 1 by 4 pi epsilon naught into Q1 Q3 by R13 square into vector R13. This calculation can even be generalized for a system of more than 3 charges. Suppose we have the charges Q1, Q2 up to Qn. The force on Q1 due to Q2 can be calculated by Coulomb's law. This force is not affected by the presence of other charges. Similarly, the force on Q1 due to Q3, Q4 up to Qn can be calculated independently. The total force on charge Q1 is simply the vector sum of forces F12, F13 up to F1n. Vector F1 equals vector F12 plus vector F13 up to vector F1n, which equals 1 by 4 pi epsilon naught into Q1 Q2 by R12 square into vector R12 plus Q1 Q3 by R13 square into vector R13 plus so on up to Q1 Qn by R1n square into vector R1n, which equals Q1 by 4 pi epsilon naught summation from I equals 2 to n Qi by R1i square into vector R1i. Usually, the law of parallelogram of vectors is used for addition of vectors.